Okay, in this video I'm going to talk about the tangential quadrilateral formed by the centers of a circular chain of 4 tangent circles. So basically we have a circular chain of 4 circles. So we have circles like this. Something like this. So basically 4 circles that are tangent to, like, circularly tangent to each other. So like if we denote them by omega 1, omega 2, omega 3 and omega 4, so we have that so let's write it as a theorem, right? So if we have that so omega 1 is tangent, or let's write touches. Touches omega 2, omega 2 touches omega 3, then omega 3 touches omega 4, and omega 4 touches omega 1. So it follows from this that their centers so if it denoted by O1, O2, O3, O4, so then this quadrilateral formed by the centers of these circles is tangential. So then O1, O2, O3 and O4 is tangential. So tangential, it means that there exists a circle that is inscribed in this quadrilateral. So if we remove this slightly, so there exists, let's draw it in another color. So there exists a circle that touches all sides of this quadrilateral. So all sides are tangents to some circle. That's why it's called tangential. So so let's prove this theorem. The proof is actually quite simple. So recall that one of the criterions of the tangential quadrilateral is that the sum of the opposite sides are equal to each other. So like if we have the sides A, B, C, D, then it is tangential if and only if A plus C is equal to B plus D. So ABCD. This is if and only if ABCD is tangential. So, and to write this in this particular case, so we need to verify. So we need to verify if O1, O2 plus O3, O4, if it's equal, we don't know yet that it's equal, we need to verify this, and that it's equal to O2, O3 plus O4, O1. So, but this is quite simple, so let's denote the radii of this circle as R1, R2, R3, and here is R4. So then how can we express the sides of this quadrilateral? So like we notice that if we have two circles, then the distance between their centers is equal to the sum of their radius, right? Because this segment connecting their centers, it's of course it passes through the tangent point. So the circles are tangent to each other. So that touch each other. So then this would be the radius, this segment would be the radius of this circle, and this would be the radius of the small circle. So the distance between two centers is always, of two circles that are touch each other, is always the sum of the radius of the radii. So if you apply it here, we get that O1, O2 is equal to R1 plus R2. So O3, O4 is equal to R3 plus R4. And on the right hand side we have O2, O3 is equal to R2 plus R3. And this is equal to R4 plus R1, right? So if you look at the left side and the left hand side and the right hand side, we see that they are both equal to simply R1 plus R2 plus R3 plus R4, simply different groupings of the same sum of all four radii. So, and here is also so this is equal to each other, therefore the original expressions are also equal to each other, and we can remove the question mark. So this equality is established, and it immediately implies that 1 or 2 or 3 or 4 is tangential. And this is exactly what we needed to prove. So this concludes the proof.